Lesson 10-1, graphing quadratic functions. So a second degree polynomial, for example, of x squared plus 2x minus 8 is a quadratic polynomial because it has a degree of 2, which has a related quadratic function of f of x equaling x squared plus 2x minus 8. Just remember, f of x means the same thing as y. So a quadratic function has an equation in the form of y equals ax squared plus bx plus c. That's standard form, where a cannot be 0. Because if a was 0, you wouldn't have an x squared, which therefore you would not have a quadratic. The graph of these kinds of functions would be a parabola shape. So they can open upward when it's positive, when a is positive, or opens downward when a is negative. So parabolas are symmetric about a central line called the axis of symmetry. That's what this dotted line here is. Every point on the parabola to the left of the axis of symmetry has a corresponding point on the right half. So if I choose this point, it's a mirror image on this side. So if it was 1.5 steps to the right, it's 1.5 steps to the left. The axis of symmetry intersects a parabola at the vertex. The vertex here is always the low point or the high point of a parabola. When a is positive, it opens upward, as I said before. So here it's positive. Then it has a minimum or a low point. When a is negative, it opens downward and it has a high point or a maximum. And then the leading coefficient determines the end behavior of a quadratic function. So if a is negative, it opens downward, and that means when x increases or decreases, your y is going to decrease. And when x and y increase, and when a is positive, your y is also going to increase. So let's look at our first example. It says identify the axis of symmetry, the vertex, and the y-intercept of the graph, then describe the behavior. So the axis of symmetry always goes through the vertex. So it cuts the parabola in half. So we would say x equaling for the vertex, or the axis of symmetry, which is your x term. So x would equal, crosses the x-axis at -2. The vertex is up here, so that would be -2 and +8. So the axis of symmetry is actually the x-coordinate of your vertex. The y-intercept, where is it across the y-axis? In this case, it crosses the y-axis at 4. So I'm going to put 0, 4. And in a quadratic, your c is always your y-intercept. Then we need to describe the end behavior. So as x increases and decreases, the y decreases. So the end behavior is referring to the arrowheads. Next, identify the axis of symmetry. So the axis, we do the vertex, we have the y-intercept, and we have the end behavior. So the axis of symmetry crosses through here. Halfway between 0 and 1 would be half, so x would equal 0.5. Vertex is at 0.5, and it's a little bit over 8, not quite halfway to 7, so we could say this, or halfway to 9, so we could say this would be roughly, let's say 8.5. The y-intercept is right here at 8, so this would be 0, 8, and it opens downwards, so as x increases and decreases, our y decreases. Next example. Identify the axis of symmetry, the vertex, the y-intercept, and then the end behavior. So the vertex of the symmetry goes through at positive 2, so x equaling 2. The vertex is 2 and 16. Y-intercept would be at 12, 0, 12. It opens downward as well, so as x increases, decreases, our y decreases. Next, we're doing the same thing, finding the same parts. So we have the axis, we have the vertex, we have the y-intercept, and we have the end behavior. So the axis of symmetry is at x equaling 0. So if x is 0, our vertex is at 3. That's also our y-intercept. Our y-intercept and our vertex is the same. End behavior, as x increases and decreases, it now opens upwards, so our y increases. The arrowheads are pointing upward. Next, we have the axis, we have the vertex, we have the y-intercept, and we have the end behavior. The axis of symmetry is here, so x equaling a -1. The vertex is at -1 and it's like 5. Y-intercept is at 6. The end behavior, as x increases and decreases, our y increases. Next, our axis again, our vertex, our y-intercept, and our end behavior. The axis of symmetry, halfway between -2 and -4, so that would make that x equaling -3. The vertex is at -3, and it looks like it crosses the y-axis, or crosses the y-coordinate at 3. The y-intercept would be here, so it looks like 12, so 0, 12. The end behavior, as x increases, decreases, our y increases. Next part is graphing from looking at standard form of a quadratic function. Standard form is ax squared plus bx plus c. A again cannot be equal to 0. So when we graph a quadratic, we find the equation of the axis of symmetry. The formula to find the axis would be taking your -b divided by 2a. So you can only do that when it's in standard form. So you're going to find the vertex. So wherever your x is, that's going to be your x coordinate of your vertex. You're going to put that into the formula to find your y coordinate. Then you can determine if it's a maximum or minimum. From there, find the y-intercept. Your y-intercept is always your c. Then you're going to use symmetry to find the additional points in the graph. So I would just choose one point on the side of the axis of symmetry, plug that into the equation to find your y coordinate. And then your last step, step 5, would be to connect a point with a smooth curve. So an example here, find the axis of symmetry. I use the formula -b divided by 2a. So this would be, here's my a, which is 1, b, which is 2, and c, which is -6. So my opposite of b is -2 divided by 2 times 1, which will give us an axis of symmetry at -1. So if I put -1 in for x to find my y, -1 squared plus 2 times -1 minus 6. So 1 minus 2 is -1. -1 minus 6 will give us a -7. So our vertex would be at -1, -7. So I'm going to count all these by ones. So I'm going to put my axis of symmetry at -1. My vertex is at -1, -7. Since my A is positive, I know it's opening upward. Now I can use my y-intercept, which is at -6. So 0 and -6 would be here. I can mirror that one. And as long as I have my vertex and a point on each side, I can create my parabola. Next, graph this one. Here's my A, my B, my C. So -6 divided by 2 times 3 will give us 6 divided by 6, which is 1. So our axis of symmetry is at 1. So if I put 1 in here, so this is 3 minus 6, which is -3 minus 1 is -4. So I have a vertex at 1, -4. So I'll plot that point. So 1, -4. Here's my vertex. My A is positive, so it opens upward. My y-intercept is right here, so at -1. I can mirror that one over here and then draw my parabola. And there's my graph. Next, example 4, use a table of values to create a graph. The first thing I would still do is find the axis of symmetry. So I would have -8, divide that by 2 times 2, will give us 8 divided by 4, which will give us 2. 2 times 2 squared minus 8 times 2 plus 2. So 4 times 2 is 8, minus 16 is -8, plus 2 gives us -6. So I have a point at 2, -6. So I'm going to put my axis of symmetry here. So we have 2, -6, which would be right here. I'm going to put that point, so 2, -6 here, and I'm going to choose points on each side. So that means this will be 3 and 4, this will be 1 and then 0. If I put 0 in here, I know that it's going to land on 2. If I put 1 in for x, 2 times 1 squared is 2, minus 8 is 6, -6. -6 plus 2 is -4. So if I plot these down, so 0, 2, I can just mirror this one, so 2 steps over here. Then I got 1, -4. That means 3 would also be -4. And 4 would be at 2. And then I can draw my parabola. If you find one side, you can mirror the other side. Next, find the axis of symmetry here. So you have -6 divided by 2 times 3, which would be 6 divided by 6, which is 1. So the axis at 1, I plug that in. 3 times 1 squared minus 6 times 1 minus 9. This is 3 minus 6 minus 9. This will give us -12. So my y's, I'm going to count by 2's. So this would be -2, -4, -6, -8, -10, -12, and -14. This would be 2, 4, 6, 8, 10, 12, 14. And then here I just count by 1's. So my vertex is at 1, -12. Put a point at -1, -12, which will be right here. Then just choose points on each side. So this is 2, 3, 0, -1. 0 would give us -9. So if I put a point at -9, -9 would be right here. It means I can mirror that one on this side. So 2 would give you -9. If I put a -1 in here, so 3 times -1 squared minus 6 times -1 minus 9. This is 3 plus 6 equals -9. This is 9 minus 9, which gives you 0. So we have -1 and 0, which is here. That means 3 would also be 0. Now I can draw my parabola. And there's our graph for that equation. The next part is using our calculators. So here it says in 1304, Edward I built Warwolf, one of the largest catapults ever used in battle. The height of a projectile in feet x seconds after it is launched from Warwolf can be modeled by the function h of x equaling -16 x squared plus 96x plus 40. Graph the function with a graphing calculator. Interpret the key features of the graph. So for this one, I have it done for us. So you hit your y equals button and type in the equation. The next step to find your values, if you hit second trace, or not second trace, second graph, you'll get the table of values there. And then since something's going up into the air, you're not going to have negative feet. So it's always going to be above ground. So x is going to be the seconds, and you can't have negative seconds. So you're just going to start with 0. And then you're going to go to the positive numbers, and you can see what the y values are. The third picture here, you can see my windows, and my x minimum is 0 because I can't have negative seconds, and my y is in feet. If I'm starting at a height of 40 feet, I know it's going to be going up way above 40, so I just estimate and put like 200 divided by 25s. You might have to change those depending on which numbers you're using. And then if you hit graph, you'll see the parabola. So to find the vertex, you're going to hit second trace, choose option 4 because we have a maximum. And then you're going to move the cursor so you're on each side of the vertex. So you hit enter on the left-hand side, then hit enter on the right-hand side. And then when you hit enter a third time, it gives you your vertex. The vertex here would be 3,184. To find the zeros, where does it hit the x-axis? You're going to hit second, trace, choose option 2 for the zeros, and you're going to use the arrows to move the cursor, and you always go from left to right. So here, if I go hit it right above here, so y is positive, hit enter, go below the x-axis, so you just look to see where your y is negative, hit enter a third time, and here it says you have a 0 when x is 6.39. When you have a really small number with 1e to a negative power, it's 0. So we would say it's about 0.39 or 6.4 seconds. So now let's the key features here. We did find the zeros. We said it was like 6 points. We'll say 6.4. Which it just means after 6.4 seconds, it hit the ground. The y-intercept, where is across the y-axis? So that's the starting height. And the starting height was our c, so that was 0.40. So that 40 would mean starts at 40 feet. The vertex we said was 3,184. And that means max height, or after 3 seconds, the max height is 184 feet. And then it's increasing. When is it going up? It's going up, increasing when x is less than 3 seconds. So when x is greater than 0, but less than 3. So it's going up in the first 3 seconds. And it's decreasing when x is greater than 3. So after 3 seconds, it falls to the ground. Symmetry was x equaling 3. So that just means the height is the same before and after 3 seconds. Positive, it's always, because you can always have a positive height in the end behavior as x increases and decreases, your y decreases. Then we have the domain. So here, this one, the domain would be so x such that x would have to be greater than or equal to 0, but less than or equal to 6.4. And then the range would be y such that y has to be greater than or equal to 0, but less than or equal to 184. And the domain is just referring to time, and the range is referring to height. Next, Miyako hits a jump and follows a path of a parabola. Her height can be modeled by the equation h of x equaling negative 16x squared plus 32x plus 15, where h is her height in feet after t seconds. Graph the function with a graphing calculator and interpret the key features of the graph in terms of quantities. We're going to grab our calculator here. We're going to go to our y equals, clear what we have in here. We're going to type in negative 16x squared plus 32x plus 15. And I'm going to change the Windows settings. Minimum is 0. Maximum, we could keep this at 20 to see what that would be. The y minimum is 0. Maximum height, so we know he starts at 15, then goes up. Let's just make this 100. Be on the safe side, and then we'll just count by tens. And then hit graph. So let's change our Windows settings so we can see that a little better. The maximum, let's make that 10. Count by ones. The y max, let's do this at 50, and we'll count by tens as well. Graph that. There you can see that better. And now we can do our key features here. So our zeros, to find our zeros, we're going to hit second, trace, find a 0, number 2, and need to get up higher. So I'm just looking at my y-axis. Okay, we're above, so we're going to hit enter. Right bound, go below the x-axis. So now it's at -2. Hit enter, enter a third time. Our 0 is at 0 and, or 2 point, we'll just say 2.4 and 0. So 2.4 and 0. So what does that mean in this problem? We would say tile is in the air for 2.4 seconds. And then the y-intercept, whereas across the y-axis, the starting height was 15. So this would be 0, 15. And we would say started 15 feet up. The vertex, we go back to our calculator to find the vertex. We'll do second trace. We'll do since that's a maximum, we do number 4. Need to go to left bound, so left side of the vertex. Hit enter, go to the right side. Hit enter a third time. The vertex is 1 and 31. 1 and 31. So all that means is the maximum height is 31 feet at 1 second. And then increasing when x is less than 1, decreasing when x is greater than 1, symmetry when x is 1, so that just means the same height before and after 1 second. Positive, always positive. So we always have positive height and time. And behavior as x increases and decreases, our y decreases. And then our domain and our range. Domain would be x, such as x is going to be greater than or equal to 0, but less than or equal to 2.4. And then the range, a y such that y is greater than or equal to 0, but less than or equal to 31. And again, domain is time, the range is height. Next, comparing the key features. So use the equation and it's able to compare the key features of the functions. So these are two different functions here. One's f of x and the other one is g of x. So the first thing to do would be to just graph the two functions to compare. This one, they're just plotting the points. So they had points at -4, 0. They had points at -2 and 1.5, which would be here. They had points at 0, 3, which was here. They had point at 2 and 4.5. 2 and 4.5 is here. And they had a point at 4, 6, which would be a little bit up here. So that would form a straight line. When we compare, one's a quadratic and one's linear. So let's now compare the key features. So the function of f of x is the parabola, and g of x is the line that's going up from left to right. So f of x is quadratic. G of x is linear. The x-intercepts for f of x. So if I go here, the f of x, that's at -1 and 3. So he has two x-intercepts at -1 and 3, while g of x only has one x-intercept, and that one is at 1, 2, 3, 4, -4. So f of x intersects the x-axis one more time than g of x, where we just write down more. times then g of x, the y-intercept of f of x. So I go back to the graph. F of x is here. So that's 1, 2, 3, 4, 5, 6. While the y-intercept of g of x is 3. So the y-intercept f of x is greater than the y-intercept of g of x. Increasing and decreasing. F of x is increasing for x is less than 1, and it's decreasing when x is greater than 1, while g of x is always increasing from left to right. Positive and negative. F of x is positive for negative 1 is when x is greater than negative 1 and less than 3, and it's negative when x is less than negative 1 and x is greater than 3. G of x is positive when x is greater than negative 4, and it's negative when x is less than negative 4. And the last part in behavior, as x increases or decreases, f of x decreases. And as x decreases, when I go to the left of g of x will actually decrease. And as x increases, g of x also increases. The domain of both functions is all real. And the range of f of x is when y is, if I go back to the graph, the highest y is 1, 2, 3, 4, 5, 6, 7, 8. So it's less than 8. So when y is less than or equal to 8, while the range of g of x is an element of all real. So x would be all real numbers. So that is our lesson on graphing quadratic functions.